All right, welcome. We're listening to Wookey now doing an ARMS report status talk update thing. It is a live viewing of a pre-recorded talk, but we hope that the Q&A would work well in real time. So off we go.
Okay, hi, my name is Wookey, and I've come to talk to you about the state of the ARM ports, as we haven't had a talk about this for a couple of years, as far as I can tell. I've been doing ARM stuff for over 20 years now, and these days I actually get paid by ARM to do this, which is quite good. We have a small distros team to try and help people here understand how to interface with distros. Things to talk about. What's happening in the 64-bit world. There's quite a lot of new architectural features, which I think people probably don't understand, so I thought it was worth explaining, and the implications on that for possible ABI changes, and also the state of the 32-bit ports, whether we need a new one, whether we want to get rid of any, and our build Ds. So overall, well, things are pretty good. ARM is a relatively big deal these days. There are ARM64 and AMD64 are the two main architectures, and everything else is less important. And pretty much everything works these days, and ARM strives for software parity, and I think we're getting quite close to that with x86 world. Hardware availability is a lot better than it used to be. You can now get ARM in the cloud via Amazon Web Services, so it's kind of accessible to everybody relatively easily. There's servers out there you can buy at enormous expense, plenty of dev boards. Obviously the RPi4 has made ARM64 an awful lot more popular with your average punter. And there are now mainline supported phones, so like the Librem 5 and some Snapdragon or other. So Linux on phones is kind of a real thing, or becoming so. Finally, there are some useful ARM laptops we can put Linux on. So the Asahi people have done a great job getting. You can put Debian on your MacBook or Mac Mini. And I believe there's some Snapdragon-based laptops which come with Windows, but hopefully somebody will make those work too. We've been trying for a long time to get kind of everything that works in x86 working on ARM, and that situation, both in the real world, the whole world, and in Debian, and Debian CI and reproducible builds both run everything on ARM64 these days, which is good. In fact, I think they both do all the ARM architectures. I'd have to check. There are still a few things missing. I noticed we don't build a plain VM cloud image for ARM64. There probably isn't any particularly good reason for that. I meant to have a look at it myself, but I've failed to get around to it. Somebody did actually come and ask for it, and they had a good reason a month or so ago. It needed to test booting on a new hardware, but it was actually a model, so it's incredibly slow, and they didn't have a second device, so they couldn't run the installer, which would also have taken like about a week. So yeah, that's quite a good reason to just have an image available, and they were quite right that there wasn't an easy place to find one to just boot Debian, and we should probably fix that. Upstream optimizations have been happening, so in general most things work reasonably. If they don't just work, they are somewhat optimized. But I think there's probably still some work to do in various places for that. So there have been lots of new features since this ARM64 port first came out in 2013, so it's been around nearly a decade. And that was the 8.0 ISA, so ARM keep inventing new stuff. So there's the 8.1 ISA, the 8.2, and so on, which generally add new instructions, but sometimes add new hardware features which aren't just instructions. So I was just going to go over what those new things are, and kind of whether they're important or not from our point of view, and how they've been rammed into the existing ABI. This OpenSUSE page is incredibly handy. That's what I use all the time for finding out what some new thing is and which version of GCC you need to use it and how you turn it on and that sort of thing. Very useful. So yeah, 8.2. So features are implemented in various ways. So PAN is a kind of memory protection, so that things can't get to memory they shouldn't get to, and that's just turned on if your hardware has it. So that's easy, we don't have to care, it just works, the kernel deals with it for us. But most of these things are optional extra instructions, and it's very important not to execute an instruction on hardware that can't run it. So you don't want to run 8.2 instructions on 8.0 hardware, because you'll get an illegal instruction fault and everything blows up. So you can gate the new features with hardware capabilities, and you can use ifuncs, which is this functionality in glibc to basically compile two versions of a function, and then at load time check whether the hardware capability is available, and if so, go, we'll use this version of the function, not that version. And that has the advantage that you only do the check at load time. You don't do it every time you run it. You just change the function pointer. But some things you can't do ifuncs with. So, for example, LSE atomics, large system extensions. So atomics are really useful. That's a mechanism in GCC for basically doing efficient machine code on lots of different architectures. So rather than people write some tiny bit of actual assembler, which tends to be terribly specific to the bit of hardware they tested it on, the compiler will optimize for whichever actual core you're compiling for. And so if you use the atomics, you say do this thing, quite a low-level thing, and it'll do it in a sensible way. And in that case, you have to do the check every time, because those atomics get inlined in your code. So it's not a function call. Fortunately, the LSE instruction is really slow, so doing a check for it before you use it every time makes sense, and in fact the overhead is negligible. So that is in fact on by default in GCC 10. And then there's other stuff where really the actual software upstream has to use the functionality explicitly. So for example, the variable length vector thing is a kind of SIMD stuff, but you have to use it in order to make your code vectorizable. And also, to get ifunc working, you have to put support in your software for ifuncs, which is kind of ugly and makes builds complicated. Similarly, for half precision floating points, so FP16, the ML people really care about doing lots of floating point but not very accurately, so they use it a lot. So all that stuff is generally in use where it can be, and this mostly works. I'll get on to a couple of cases where things don't work very well later. Virtualization has been improved in newer cores, so ARM64 can't do nested virtualization, so you can't have a VM inside a VM, which annoys people because it works on x86 and always has. But that's fixed in 8.3 and fixed more efficiently in 8.4. We'll get on to how available that is in a mo. We also got Hyper-V support recently, which is Microsoft's cloud stuff. So basically, I think just means that Linux things work in Hyper-V and they didn't before. It's not something we have to worry about. It's just in the kernel. We should turn it on if we haven't already. PAC and BTI are interesting. So these are both mechanisms to deal with common attack methods. So you can run code that's already marked as code in a program, so you're allowed to run it. And you can kind of construct a program by jumping to bits of code that already exist near the end of a function, which does something, and then it returns. And you can jump in with a return address. So by signing pointers, you can mitigate against that attack. So that's what PAC does. Pointer authentication stands for. So each pointer has a little tag in the top few bits, which means people can't use pointers, can't jump back from places they weren't supposed to jump from. And similarly, BTI marks jump landings as kind of signed, tagged as OK, so you can't just jump to random places, you can only jump to permitted places. So both of these are really quite useful protection, and they're, in order to be backwards compatible, the instructions are implemented in the NOP space. So instructions which prior to 8.3 were NOPs are used for these. So that means when you run this code on a pre-8.3 processor, it just sees NOPs and doesn't do anything or waste any time. The BTI jump protection thing is the same as CF protection option on x86. There isn't a pointer authentication equivalent that I am aware of. There's kernel and user space parts to the pointer authentication, and you could use it for, so at the moment it's just used for this kind of stack protection functionality. You could use it for lots of data to protect pointers to data and objects. Doing that would not be ABI compatible, so we kind of can't do that, and I'll come to that in a minute. So this is generally believed to be a good thing. So we did a complete archive rebuild with this enabled. Well, Lucas did it, so thank you very much, Lucas. And basically everything built. A few packages failed, and generally they were almost all because this is an architecture specific option. You can't just give -m branch protection to anything other than ARM64, it'll blow up. So packages which ran another compiler like Mingu or something in the build tended to explode. So that was just because of the way I kind of hacked it in for the by just ramming it into depackaged build flags. So this is generally reckoned to be a good thing that we should just turn on everywhere, like our other hardening flags. And you can turn it off in the kernel, so if you do have hardware where it's a problem, we can do that. The only case anyone's found where this actually broke anything was some DRM that was doing something very dodgy with pointers or jumps, so that got annoyed. In general, everything should work. However, this leads to an interesting question. When we want to set a new flag by default on an architecture, we can do that in GCC or we can do it in depackage. And it's not entirely clear when we do one or when we do the other. I don't know. So I'd like a bit of feedback about that when we get to the discussion later. I'll talk about Neon in a minute, and that's another thing where we should be changing the default flags. So for PAC and BTI, we had a discussion on the depackage mailing list, and GM reckoned we should add a new hardening option, with a generic name of just branch, which applies to the CF protection on AMD64 and the branch protection on ARM64, which sounds perfectly sensible to me. And that seems fine because in general we try and build everything with the hardening flags enabled unless there's a good reason not to. I don't actually know what fraction of the archive doesn't have the hardening flags enabled. If anybody knows, they could tell me. But that seems fine. But there is an argument that actually it should just be in the default flags for the architecture in GCC. I don't know. You tell me. The other interesting feature, which is in 8. I've forgotten already. 8.5 is MTE, so memory tagging extensions. So again, this is a tag in the unused bits of pointers, and by marking pointers and memory to be matching colours, you can tell when people are messing with your pointers. You can use it on the stack or you could use it on the heap. We haven't done the stack work yet, so this is pretty new. Hardly anybody's got an 8.5 part yet. The glibc part of this is already enabled. That just works. and the kernel address sanitizer can use this if you have a new enough kernel. So basically the checks are kind of done in hardware rather than being done manually. So again, this is quite a useful security improvement. So just some idea of to what degree these new things are available. The answer, in fact, is not much at the moment, but that's just starting to change. So for a long time, everything was 8.0. There were, in practice, almost no 8.1 chips that got out into the world. The main one, Thunder X, I think got canned before it was released. So I've got one, but I don't believe there are effectively any out there. There's some 8.2, so Graviton 2, the AWS is 8.2. That was probably the first that was widely available. Ampere Ultras also. But now Graviton 3 has 8.4. So that means you've got the pointer authentication available. And Apple's M1 is 8.5, except BTI is not implemented on there, so that's got pointer authentication as well, and all the other stuff. So the new chips, and obviously new stuff will continue to arrive, so this becomes more important over time. A little bit of context to the history of ABIs. So the original ARM thing was in 2000, which was the V3 ISA. I should just clarify the difference for people who aren't following along too closely. The ABI is the binary interface effectively between function calls. There's lots of things in the ABI, some of which is explicitly specified and some of which is just kind of de facto. But then there's also the ISA, instruction set architecture, which is used. So that's the set of instructions that are allowed. And they kind of go together, but not exactly the same thing. The original ARM thing used a different ABI and the targeted V3 ISA, and then in 2009 we did armel, which was the new eABI, and V5 ISA, and then armhf in 2012 was V7 with floating point, but not with neon. We'll get to that in a mo. ARM64 in 2013 was ARM V8 ISA and a whole new ABI. Now we've got a couple of things coming along which are almost certainly going to be new ABIs, and thus, so in Debian terms, a new ABI is a new architecture. That's what we call it, a new port, a new copy of everything. There's a 64-bit Time-T version of armhf, and there's ARM v9, which has been announced and will start appearing in things, I don't know, soonish, and that's almost certainly going to require a new ABI, although it will, I presume, run ARM v8 stuff, so it's up to us what we do there. So, ABI breaks are a big deal. It's very important and useful to be able to run binaries for a long time without having to change the world. Now, ARM has come a long way in the last decade. They didn't used to get this at all, and just kind of had this embedded mentality where you go, we've made a new feature on our chip, so you should rebuild everything to run on it and use these new features. And we all go, no, we're not doing that. That's not how the world works. People need software from 3 years ago that still runs. You can't just change everything all the time. And they get it now, and this is discussed quite a lot. And all these new features have been implemented in Linux, at least, in such a way that they don't break the ABI. But there's a cost to that. You can't use all the functionality, and there's quite a lot of extra work for people in building stuff in a way that it can still run in the old stuff, but also use the new features. And as time goes on, that kind of load gets higher as there's more stress between the stuff people would like to use, and ideally just use without having to worry about it, and the work they have to do to make sure it still works in the existing ABI. Now, we, the distros, get to decide when this changes, not ARM, much as it might like to. It's something we should think about. Obviously, we have a very strong incentive to keep things the same as long as possible, because that's what users want. They want stuff to just work, and compatibility is important, and a new architecture is a whole load of work. However, I think one thing that's changing is that this is being discussed more, or ARM would like to discuss this more in public, or at least some people would. ABI decisions used to kind of get handed down from on high, and this is how you build stuff, the compiler says. But when the choices you make about which things go into your ABI last a really long time, a decade at least. So it will be nice to get those as right as you can, and a bit more discussion with external entities like ourselves would probably improve that process. It's not entirely clear where that should happen, so I think that will be something we could usefully talk about, how we would discuss, from our point of view, what would it take to make it worth a new ABI to us? And the answer is, does it go twice as fast? Maybe. If it's less than that, we probably don't care. Or there's some vital new security features. I think is an argument in favour. At some point, users benefit enough that it's worth changing. So back to 32-bit world. The neon is a bit of a problem. So this is similar to it's an optional instruction in armhf in v7, and always has been, and not all hardware has neon. Most of it does, and that's been causing problems recently because GCC changed their kind of FPU architecture option defaults. So effectively, if you just say I want Arch v7, because the FPU is set to auto, then on most machines that will go, or auto here means I have got neon. So stuff gets built. If you just build stuff without saying explicitly on an ARM v7 machine, you get neon turned on. And that's a problem because the binary you produce might explode on a non-neon machine. And we have those in our build, so we get breakage. So I think we actually need to get our compiler to explicitly say no simmed in our build options, and it doesn't at the moment. The actual problem comes because even though the usage of neon is usually checked behind a hardware cap, GCC will use it before that check, right at the startup code, and then your program explodes, which is just bad. So there's been various instances of this, and we really should try and sort it out. The other thing that is coming up, 2038 approaches rapidly, and that is when Unix 32-bit time T runs out. We, assuming anybody's still going to be using 32-bit ARM by then, and they probably are, I don't know how many of them are going to be Debian, we should fix it. So Arne Bergman did a whole load of work on this back in 2020 and tried bootstrapping Debian and found various things broke because it was all a bit new. It's probably, and was thinking then that somebody would finish this off and make it work for Bookworm, but we didn't. Basically I could spend work time on this and try and get it done. And I probably should, unless anyone thinks that we just don't care and we'll just wait for old armhf to die and hope not too many people are using it in 2038. In principle, you could try and do it within the architecture, but it's incredibly hard because it's like the glibc 5 to 6 transition, 4 to 5, whatever it was, where every package in the entire archive is affected. So it's about 100 times easier to do it as a new architecture. The problem with that is that it's a new architecture and it has to be bootstrapped, and stuff will break because we changed the name, and we have to think of a name, and that's always a stupid argument, and it's not entirely clear what it should be. I mean, you could just put a T on the end, but armhf, what the hell's that? Maybe we should go back and just call it ARM32, because in a few years' time ARM will be ARM64, kind of, that'll be the normal thing, so you might want to mention that you're using ARM32, and it'll be like the new ARM32 ABI that has sensible time T's in it. Maybe that's not crazy, I don't know, but please express your opinions, because if we're going to try this, we should probably get on with it, and I need to pick a name. armel, still here, but it is getting a little bit harder to maintain because some upstreams don't care. The Rust people didn't do an ARM v5 for ages. I just looked and they seem to do one now, so maybe they fixed that. But people assume Neon, they assume v7, and we have to dick with people's build systems to get stuff working. Because it's not easy to subset our architectures and just not build some stuff we don't care about, maybe, I don't know, I think it would be I'd be interested to know from, I guess, the release people whether they think armel is becoming a problem. I still use it, I guess plenty of other people still do, but yes, maybe it's coming to the end of its life and we should just keep it going as a port rather than a release architecture. And let's say we were going to add armhf or whatever we want to call it. Is that a good reason for going, well, we don't want 4 ARM architectures, 3 is plenty? I don't know. Please express your opinions. Buildies. So I maintain ARM sponsors a set of buildies. They live in the server room here, and I look after them. And our 32-bit boxes are mostly Marvell Armada boards, and they're getting a bit vintage. We've had to retire a couple because they just kind of stopped working, and they're a bit flaky, and you have to go and fettle them increasingly often. So at some point that hardware is going to die, and there isn't anything to replace it. Nobody's making fast 32-bit hardware anymore. So we already do quite a lot of our builds on 64-bit machines, but you can't do everything because it doesn't all work. Some of that is due to very dumb decisions by ARM about differences between ARM64 and ARM32, which nobody thought would matter, but they do. But it is what it is. It's worth being aware that there is hardware which doesn't have 32-bit support out there at all. And one thing I think is important about our building infrastructure is that as a developer, it's hard to know which hardware supports which features. So, for example, Harris has Neon, but Able doesn't. And so if you get a build something that runs on one and not on the other, it's hard for you, unless you're following this stuff in loving detail, to know that that's probably the reason why. So I think we should make it easier to find out what's different about our porter boxes and buildies. Probably just an extra field or two in the machine database or something, but I'd like people's input on what the best thing to do about those, because it annoys me, and I'm supposed to know this stuff, and I have to go look it up. So one thing that will help with the having to build 32-bit stuff on 64-bit machines is a recent kernel patch, so ABI-incompatible. So 32-bit kernels have this fix-up functionality. So ARM alignment is different from x86 alignment on 32-bit systems. So when you do a misaligned access, it wraps, or doesn't wrap, I forget. I think it doesn't wrap on 32-bit ARM, and behaviour is different on 64-bit kernels, and possibly one reason for some things failing. So recently the 64-bit kernel got the 32-bit alignment trap code ported. I had a look, and on our buildies we do get an alignment trap about once a day, so there are still things doing unaligned accesses even after 20 years of trying to fix them all up, and occasionally those will matter. There was also just a little detail which came up recently, was using 32-bit kernels on 64-bit hardware. That's a bit of a weird thing, using a non-native kernel, but it turns out that for latency reasons it's not completely crazy, at least for some people. So, and they reported this and asked for a couple of options to be turned on so it would work, and we said no. but we didn't say why. So the question is, what is the downside of enabling a 32-bit ARM on 64-bit hardware kernels? It's not very commonly used, but if it works and doesn't really break anything, maybe we should turn it on. Also, I'm going to retire soon, so it is possible, but by no means certain at this point, that there will become a job available doing Debian ARM. So if anyone is interested in that, do please talk to me. It's probably more useful that you know about Debian than it is that you already know about ARM. You can learn that stuff. Anyway, that's all I've got to say, because I'd like to leave a few minutes to discuss what we are doing about ports, the next releases, and so on. Yeah, that is me.
Well, thank you very much, Wookey. Now we're just going to connect to his Jitsi, and then we can hopefully have a Q&A. And if that doesn't work, we can cover questions on IRC, and we'll just wing it like we generally do. Okay. I think let's just check that he's working properly.
Hello.
Hi, do you hear me, Wookey?
I do, yes.
Okay.
Sorry, I've still got the stream playing. I'm slightly out of sync. Hold on a minute, let me just nobble that. Right, that's better. Who's me? I can't see anybody, so bear that in mind.
Ben Hutchings.
Ah, yes, hi, yes. That query about kernels.
Yeah, so my understanding is that the 32-bit ARM port doesn't have it just doesn't have quirks and bug workarounds for V8 CPUs, and that's why it's not recommended to run a 32-bit kernel on 64-bit hardware.
Right, it's because on some machines it'll just blow up or not work or something. Or
It may be subtly broken is the problem.
Fair enough. Possibly it's not entirely clear that this alleged latency improvement is actually real. I think that remains to be proven. But if it was, then I guess does turning on, I mean, as you say, it's not recommended, right? But turning on a couple of config options that add a couple of BCM drivers, does that actually matter? It's like turning on hardware for any other bit of hardware. Is it not?
Well, I would rather not. I would rather not enable a hardware configuration that we know is going to be subtly broken.
In some places. Okay, fair enough. So, yeah, I'm not sure how to moderate this. Do people have a lot of questions? I put some in the Etherpad. There's a whole load of stuff about ports, I think, which kind of needs discussion. And this interesting question about where we put defaults, whether they should go in GCC or depackage. I have no idea how we even decide.
Okay, we don't have questions from the audience right this minute, and I'm not sure if the next one is a quote or a joke, sorry, because I don't know enough, but there's a comment, ARM32, and toss in SIMD at the same time.
Right, yes, so that would be suggestions for our kind of... one thing I didn't really explain properly in the talk was if we did a new armhf with 64-bit time T, I guess we could kill the old armhf after a while. I'm not sure how long that would be, because it would be a complete replacement, but not a compatible one. And yeah, there's arguably we should forget about the not everybody has neon. I mean, it's true, but I don't know how many not neon parts there still are. Does anybody know? I think it's everything from Marvell.
Yeah, not many responses from the audience.
Yeah, I mean,
okay, is there no other comments or questions? Do you want to catch up with Wookey while you've got him here?
Hi everybody. Sorry I didn't make it all the way over there.
You're missing a hell of a party.
If anybody wants to work on ARM professionally, do contact me. It will be useful to have some continuity. Otherwise, who knows who looks after this stuff. It's a lot easier if you get paid to do it rather than having to fit it in around your other objectives. What else did I want to ask people while I've got you all here, even though none of you are going to tell me the answers? I'm just going to have to decide for myself, I can tell. Yeah, does anybody actually understand exactly what went wrong with GCC that causes neon instructions to appear in the init code? Or do I need to work it out? I guess somebody does, but anybody in the room?
Just some chuckles on that.
Yeah, fair enough. Okay, well, if you haven't all got lots of questions or advice for me, then I hope that was interesting. And discussion will continue very slowly on mailing lists.
Great, thank you so much, Wookey.